Hey everybody, this is Larry. This is me going to do week 3 of the weekly premium prompts. Paid for it, might as well do it. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this prompt. Apparently I've done it before, which is actually way rare for the weekly premium prompt, which is also a little bit unfortunate. But yeah, well, let's do it all the same. Today's prompt is, or this week's prompt is 1136 parallel courses. You're given an integer n, which means that there are n courses from 1 to n. Okay, so they're 1 based. Given some relationships of the previous and the next. Okay. In one semester, you can take any number of courses as long as you have taken all the prerequisites in the previous semester. Return the minimum number of semester needed to take all courses. And there's no way to take all the courses, return -1. Yeah, I mean, I think this is going to be a variation of the topological sort. I mean, everything about it is structured like a topological sort, so that is just going to be topological sort. The question is how do you minimize the number of semester, right? And I think in this case, it's just going to be greedy, right? Greedy part of the the topological sort, because and this kind of lends itself to the BFS way of doing topological sort, because if the depth of search way, maybe it's a little bit tricky, maybe not. I'm just trying to think whether this is the same as the maximum depth of, like, if you think of the topological sort as a topological sort tree of dependencies, right? I mean, it's not actually a tree, I guess, technically. I mean, it could even have a cycle in this particular case, but let's just say there's no cycles. It's not a tree, but I'm wondering if that's just a depth. But but either way, that's not necessary that's not a necessary reduction. What it is that, yeah, I mean, it's just greedy, because if you the idea being greedy, being optimal in this case, is that there are no constraints on the number of courses you can take, right? So there are no decisions really. Your only decision on this particular problem, like in terms of when to take the course, is either to take it as early as you can or a little bit later than you can, which doesn't make any sense. So you always take any course that you can when you can, right? So I think that's going to be the way to do it, and maybe we have to kind of clean up, or make sure that we're careful about the variation of topological sort. But otherwise, I think that should be good. So let's kind of get to it. So I'm just taking a look at the constraints. I mean, this is fine, right? N is kind of big, which means that you shouldn't do anything n square. But the other component is going to be relation. So it's going to be v plus. If you do a v plus y solution, it's going to be fine, because y is also only 5,000. So yeah. Yeah, and the way that I always do it is just, which one is the prereq one? The previous. So okay, so the next course. So that means that for UV in relations, then taking the prereqs, I guess. Taking V is going to require taking U, right? Okay, and that means that U has one dependency, right? And this is the way that I write it. I don't know if this is the cleanest, but it's just to make sure that this is in the mapping. I wonder if all the courses are going to be in there, but I guess it doesn't really matter, because then you just take it all on the first day if there are no prereqs anyway. Okay, right? And of course, I didn't actually even define it, but prereq is equal to collections.default list, right? So this is just setting up the dependency list, and then degrees is just a counter. And this is this is in degree, right? Did I do it? Why did I? Oh no! Oh, I changed the order for some reason. No, this makes more sense. I don't know why I changed the order. And then yeah, and then now with topological sort, the thing is that we always take a class whenever we can, and in the one semester at a time, almost like a staggered kind of way. So let's do it, right? So how do I? So let's say Q is equal to connections.deck, right? So it doesn't even have to be a deck anymore, I suppose, because we're doing it in like a sort of a staged way, right? So yeah, and you could maybe use 2 Qs if you like, but I don't even think it really, or maybe even like a deck of decks, but you only use 2 elements anyway, so maybe I'll just use 2 decks instead. So yeah, so then now for key and degrees of keys, Q of key, if degrees of key is equal to 0, Q dot append key, right? It's just, this is standard topological sort stuff. And then yeah, okay. And I do wonder the way that I'm doing is a little bit funky. Maybe I'll just write this instead, right? I think that's fine. If not, I mean, it's only 5,000. It's not even n squared. So okay. So then now this is well, the annoying thing is that this is 1 index, which is why I kind of wrote this way. But I'm going to convert them to 0 index just because, I don't know. It's just the way I've always been. You feel free to kind of do your own thing. But yeah, okay. So then now, how do we want to write it, right? So maybe, while true, if length of Q is greater than 0, then we push it off, right? We might have to readjust this later, but basically this is, and now we want to create a new queue, is the way that I write it. And basically it's just, regular topological sorty stuff. And then here, there's going to be a counter, maybe like the return counter. Yeah, I'll just call it a counter because I'm lazy, right? So this is going to be, every time we do this loop, we recurrent. And maybe I'll just do, if Q is equal to 0, how do we want to, what is the term? Then we break, but are we done in that case? Or do we return? That's a good question. I mean, there needs to be an additional thing is what we need. So yeah. So basically, if there's no more items, if all of degree x is equal to 0 for x in degrees, basically if all the degrees are 0, then I think we're done, right? Then we return counter. Otherwise, we return -1 when we run out of Q things. And you can actually probably maybe just change this as well now. While if Q is greater than 0, right? Something like that. It does look a little bit awkward, but you'll see, hopefully, it is very awkward for sure. Yeah. And then now we take those classes, right? So, yeah, for x, or q.popleft is the current class we take. So C for class, and then we push it on. Oh no, we don't push C. What we do is we look at, all the prereq. Did I mess this up? You have to take this before this. Yeah, so actually, I did mess this up. So that after we take the class U, we can now open the class V, right? And V has the number of prerequisites. Wow. Yeah. Mistakes were made. But yeah, in this case now, prereq of C, right? So for whatever, V in prereq of C. So now, this isn't a prereq anymore. This is like after req, post req. Dependencies? No, what's the other thing? What's the opposite of dependency? Let me Google that. Opposite of. I'm like so bad today. Dependency. What's the guy? Independency. Okay, fine. That's what Google is telling me. The depender. Okay, so I feel not as bad. This is terrible. I find it not as bad as not knowing this because I don't think that's a real thing. But all right, let's just keep it there for now. And then for we in there, we degrees of we take by 1. If degrees of v is equal to 0, then we put it into the queue, and that should be good. At the very end, we said q is equal to nq. I think that should be good. And maybe, yeah, return -1 in this case. I don't know. That is just very bad. Yeah. Oh no. If I think this should be there as well. So if length of queue is done, then we do this. Yeah. You can also just do a count of number of things you kind of clear, but yeah. Am I done? These examples are terrible. That or not terrible. I mean, they're good for you know, letting you know what the problem is, but they're kind of terrible for kind of being for testing. But I'm lazy today, so I'm going to click on submit and hope I don't get anything wrong. And there you go. Apparently, I only did this 4 months ago. Huh. So I don't know. Yeah, this is topological sort. That we use 2 queues, but every item can only be in the queue once. So yeah. So technically you copy over, but still, yeah. Push and pop 1. So this is linear. V plus E. We process this here. So and also here. So everything's gonna be V plus E linear. Yeah. That's all I have for this one. Let me see what I did last time. I guess I did the same thing last time. Oh, except for that I kept track here. Yeah, okay. I see what number of classes we took and number of semesters. Okay. Past Larry was a little bit more creative. I do wonder what if that was like on the. Anyway, that is all I have for today, though. So let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.